Assalamu alaikum class. Welcome back to the lecture. In my previous lecture, I have finished with the case control studies, and today we are going to start the cohort studies. Again, another subtype of analytical epidemiology in which the researcher wants to accept or reject the hypothesis which he has generated from the cross-sectional surveys, and then he has crossed this hypothesis through the case control studies, and now this is the final study in which the final acceptance or rejection of the hypothesis which is generated by the researcher is done. Cohort studies are considered as superior studies because in cohort studies, the outcome of interest occurs in front of the eyes of the researcher. And it means that the disease will always occur in front of the researcher. So incidence can be calculated in cohort studies. Let me re-emphasize that cohort studies are known as superior studies from the rest of the other studies because in cohort studies, incidence is calculated, the new cases are generated in front of the eyes of the researcher, and on the basis of incidence rates, the researcher can calculate the relative risk and then accept or reject the null hypothesis in the final terms. So today we will be discussing cohort study design. What are its different types? What are the measures of association? As I have already mentioned that we can calculate incidence rate, we can calculate relative risks. There are other measures of association we can find out in cohort studies. What are the advantages and disadvantages of the cohort studies? So this will be the total framework of the cohort studies. And again, I will divide the content of cohort studies into 2 lectures for the easy understanding. And we will be giving you assignments. Fine. Moving forward, as I have already mentioned that these cohort studies are considered as superior studies because initially the researcher starts his research from test tube research, then he moves from test tube research to the animal research, and then from the animal research, the other thing which comes in front are the editorials which are published in different journals. There are case reports, there are case series, and the hypotheses which are generated from the case series are then tested by the cross-sectional surveys. The cross-sectional surveys makes the base of the hypothesis, and then this hypothesis is tested in the case control studies, and finally the moment when the researcher decides that he has to reject or accept the hypothesis which he has generated from the cross-sectional surveys comes under the domain of the cohort studies. He conducts the cohort studies. These are superior studies in when we consider the analytical studies because they make the final verdict that this hypothesis is accepted or rejected. Again, just a recap, in descriptive studies, we have covered the case report, we have covered the case series, we have discovered cross-sectional surveys in which time, place, and person distribution is described. If the researcher studies a population and its exposure to the environment, these are known as ecological studies, which are again studied in a single time point. And then on the basis of descriptive studies, a researcher makes a hypothesis. This hypothesis is accepted or rejected on the basis of the observational analytical studies. These analytical studies are further subdivided into case control studies and cohort studies. In case control studies, the case is already established. It means the disease is already present in the community. The cases are then compared with the controls and they are matched with each other, and retrospectively their measure of association is measured in terms of exposure, and the measure of association which we calculate in case control studies are odds ratios. These odds ratios are calculated by the generation of 2 by 2 table, and we measure the odds ratio and interpret the results. If the odds ratio is more than 1, it means there is a stronger association between the two. And if the odds ratio is less than 1, it means there is no association between the exposure and the outcome of interest. Then, in case of cohort studies, the exposure and the disease both occur in front of the eyes of the researcher, and on the basis of the exposure, the researcher divides the group into two, exposed and non-exposed, and then follow it over a period of time to see the occurrence of new cases in the population. It means if the new cases are occurring in front of the researcher eyes, it means the incidence can be calculated from the cohort studies. These are the only studies in which the incidence rates can be calculated. So moving forward with the cohort studies are known as prospective studies. Why these are known as prospective studies? Because the researcher moves forward in time, and he identifies a cohort, he identifies a population, divides them into two groups, exposed and non-exposed, and then follows them over a period of time to assess that whether the disease occurs in the exposed population or it occurs in not exposed population. So it is a prospective study in which the researcher moves forward in time. Again, it is also known as longitudinal study because of the longer duration of the research. It is known as incidence study because the number of new cases occur in front of the eyes of the researcher in the population at risk. The numerator and the denominator both can be calculated by the researcher. This is the only study in which the incidence can be calculated of a disease. So these are known as incidence studies. And again, as they are prospective studies, the researcher moves forward in time. So they are also known as forward-looking studies. So any name can be used by a researcher to describe the study design. But the most important name which is used in the epidemiological classification is known as cohort studies. So what does a researcher do? He identifies a population, and then from population he defines a cohort. The cohort is a group of people who are free from risk, free from disease. They are apparently healthy population which is derived from the original population. The disease population lays behind, and the cohort consists of only the susceptible group who can develop disease over a period of time. Apparently, at this point in time, they are happy, they are healthy, and they share the common characteristics. Fine. This cohort is divided on the basis of its exposure into two groups, the exposed group and non-exposed group. Fine. Let me give you an example. For example, a researcher wants to find out an association between smoking and lung cancer. So he goes in the community and find out the population which is already diseased or is suffering from the lung cancer. They will be excluded. They will not be included in the cohort. So cohort identification is done from the population. This is healthy population. They do not have the disease. But they are a group of people who will be followed over a period of time. For example, if we know that in Pakistani population, the lung cancer is more common in males and cigarette smoking is more common in males, and the most appropriate group in which the lung cancer presents itself is of about 50 or 55 years. So we will select a cohort of males who are actually 35 years of age, because we presume that we will follow them over a period of 20 to 25 years to find out that whether the lung cancer develops in them or not. They have same characteristics, they belong to same age group, they belong to same socioeconomic status, and they have all the characteristics which are similar to each other. Then they are divided into two groups: exposed, those who are smokers, and the non-exposed, those who do not smoke. And then over a period of 20 to 25 years, even 30 years, we can follow them. And then we can see that what is the number of cases of lung cancer which appeared in the exposed group, and what is the number of normal cases which remained in the exposed group. And then what was the number of cases of lung cancer which developed in non-smokers, and what was the number of the people who remained normal and did not develop lung cancer in the non-exposed group. So we started with a cohort identification. We divided them into exposed and non-exposed group, and then we followed them over a longer period of time to assess the outcome of interest is the basic study design of cohort studies. What are important features? Number one is the identification of cohort. As I have already mentioned, that cohort should be disease free. Cohort should be disease free. And then there is a longer follow-up, and this study starts from the exposure to the outcome, that it goes forward in direction. So what are the indications of cohort studies? When should we conduct cohort studies? Number one, when there is a good evidence of exposure and disease outcome has been established while conducting cross-sectional surveys and an evidence is generated through case control studies. Once the evidence is present with the case control studies, now to make it a fact, the cohort studies are conducted to finally accept or reject the hypothesis. Number two, cohort studies are conducted in those cases when the exposure is rare but the incidence of that disease is high. For example, I will give you an example of atomic reactor which was activated in Japan, and in that area we identified a cohort which was apparently healthy normal population, and then divided them into two groups: those who were exposed within the 50 kilometers radius of atomic reactor, and those who were not exposed within the 50 kilometers of atomic radiation exposure. So then we followed them over a period of time for about 6 years, and found out that what is the number of skin cancers which has developed in exposed group, and what is the number of skin cancers which have developed in the non-exposed group. So the exposure is rare but the incidence of disease is high. Another condition to conduct the cohort studies is that the loss to follow-up should not occur. As we are moving forward in time, as there are longitudinal studies and we follow the cohort for over 10 to 20 years or 25 years, so there are chances that the participants of the research will migrate, or they will change their house, or they are not further interested in participating in the research, and some of them die because of some other reasons. So there are chances that the follow-up becomes difficult, and we lose people. So ideally a cohort should be made in such a condition where follow-up is easy, and people give consent for a longer follow-up, and they give consent for a longer duration of study. Another important criteria for conducting the cohort studies is that ample funds should be available to the researcher, because it is longitudinal study, it goes prospective in time. So we have to follow the exposed and non-exposed group over a long period of time. So we will be needing a lots of research, lots of funds. So until and unless the researcher has a lot amount of money, he should not plan cohort studies. Fine. So these were basic indications of the cohort studies. So what is a cohort? How do we define a cohort? Cohort is actually a group of individuals who are disease free, who are free of the outcome of interest. They share same experience, and they are followed for a specific period of time to assess that whether the outcome is related to the exposure or not. For example, we can make a birth cohort. For example, we can make a birth cohort of all those children who were born in 2000, in the year 2000. It will make a birth cohort, and then we will follow them over a period of 50 to 55 years or 60 years to assess that what are the risk factors which are involved in the causation of ischemic heart disease in that birth cohort. So we can follow them until and unless a substantial number of this cohort is lost due to death. So birth cohort can be identified, then occupational cohort can be identified. For example, if you want to find out the association between exposure of a certain chemical with the development of certain disease in a certain occupation, then we can make an occupational cohort. For example, we have a Bata factory near Sham ki Bhattiyan, and they use leather. So I want to find out an association between the development of anthrax in those workers who deal with the leathers. So I will identify a cohort that will be a cohort of healthy people who are currently working in Bata factory, and they are involved in the handling of the leather. And I will divide them into two groups: those who are directly involved in the handling of the leather, and those who are not involved in handling of leather. And then I will follow them over a period of 2 years or 3 years, depending upon the outcome of interest. I will follow them, and I will see that what is the number of cases of anthrax which has developed in exposed group, and what is the number of cases of anthrax which has developed in non-exposed group. Another example can be educational cohort. Let's identify a cohort, the current class of fourth year MBBS, which is present in Pakistan, and we follow them over a period of time, that what is the impact of e-learning strategies which are adopted during COVID-19 pandemic, and how they have affected the career choices in that cohort. So it depends upon the researcher's question that what type of cohort is being selected. But at the time of selection of cohort, the group of individuals should be free of the outcome of interest. Number two, they should be sharing same experience. And number three, they should be followed for a specific period of time. That makes a typical cohort. Imagine this is a population, and we are following it over a period of time. After a certain period of time, we want to see that what is the outcome of interest appearing. Look at this. Now the disease has started developing in this group. Again, with advancement of time, the disease pattern is increasing. And with further follow-up, the number of cases have increased with passage of time. At this time, the researcher wants to finish the cohort study. And now he will calculate the measure of association. He can calculate incidence rate in the population, means the number of cases which have occurred in the susceptible population. He can calculate relative risk, and he can also calculate the population attributable risk, which we will be discussing shortly. Fine. So this is the sequence of event which occurs in the cohort study. The purpose of cohort study is to establish cause-effect relationship. And number two, we want to measure the risk of association in exposed group and unexposed group in the form of calculation of relative risk. Fine. So this is the cohort actually, which is divided into two groups, the exposed group and the unexposed group. Fine. This is the exposed group, this one. This is the unexposed group. The both groups are identified from the cohort. Another classification can be, this is the study cohort and this is the control cohort, which are identified from a cohort, and this cohort has been identified from a population. These terms are also used in your books. So apparently, most of the epidemiologists use the term of exposed and unexposed population, but this term has also been used, like the exposed population is known as study cohort and unexposed population is known as control cohort. So over a period of time, look at this. Now the number of cases are appearing in the exposed group and number of cases are appearing in the unexposed group. Over a period of time, we will be calculating the number of occurrence of new cases in the exposed population and the number of cases which are occurring in the unexposed group. So, we can calculate incidence among exposed and incidence among non-exposed. And the formula to calculate the incidence is the total number of new cases which are occurring in a population in a specific time period, in a specific defined geographical area, divided by the total population at risk will make the incidence rates. Fine. So, what do we do in cohort? We select a cohort group, divide them into smokers, divide them into non-smokers who are already smoking and non-smoking, follow them over a period of time to assess that whether the lung cancer has developed or not, and then we will calculate the incidence rates between the smokers and the incidence rate between the non-smokers, and we can compare the outcome in terms of relative risk. So how do we compare the cohort studies with the case control studies? In case control studies, we start with already diseased population and a control group and retrospectively go in time and assess that what was the exposure rate between the diseased and the non-diseased. And we wanted to calculate the odds ratio. But in cohort study, we start with a cohort, we divide them into exposed group and non-exposed group, follow them over a period of time and look at the number of new cases which are appearing in the exposed population and which are appearing in the non-exposed population. It means we want to compare the incidence among exposed and incidence among non-exposed in terms of relative risk. So, indications of cohort studies, as we have already discussed them, that we want to establish cause-effect relationship, and this has already been established by cross-sectional survey and case control studies. Exposure rate is rare, but incidence is high. Cohort is stable, and there is no problem of loss to follow up. And ample funds are available. So, moving forward, as I have already mentioned, this is again another presentation, the cohort divided into exposed and non-exposed. This is the exposed, this is the unexposed. This is the disease occurrence in the exposed population. This is the disease occurrence in the non-exposed population. And now we can calculate the incidence among exposed population and incidence among non-exposed population. We can show you different types of diagrammatic presentations in OSPEs, and we can ask you to detect what is the study design in OSPEs and calculate the measure of association. So how do we construct a table of 2 by 2 with cohort studies? The exposed group which has resulted in disease is labeled as A. The exposed group which has not resulted in disease is labeled as B. The non-exposed group which has resulted in disease is labeled as C, and the non-exposed group which has resulted with no outcome is labeled as D. And we construct the 2 by 2 table in the same way as we construct the 2 by 2 table in the case control study. Again, the disease and not diseased population is basically taken into columns, and the exposure and non-exposure is taken into rows. Then we go into the row total, and then we go into the column total, and then we go towards the grand total. A 2 by 2 table is incomplete until and unless the 4 columns and 4 rows are not formulated. Let us compare it with the construction of 2 by 2 table with the case control study. In case control study, we started with cases and controls. All those cases which were exposed were labeled as A. All those cases which were unexposed were labeled as C. Look at the diagrammatic presentation very carefully because it will help you to construct 2 by 2 tables in future. And the controls which are exposed are labeled as B, and the controls which are unexposed are labeled as D. So the construction of table is again the same, 2 rows and 2 columns. Fine. So for cohort studies, what do we do? Incidence among exposed and incidence among non-exposed is calculated. The incidence among exposed is the number of cases which have occurred because of the exposure out of all those who were exposed. So A over A plus B will make the incidence among exposed. And the number of cases which have occurred in non-exposed population, total population, will give us incidence among non-exposed. So C over C plus D will give us incidence among non-exposed. As you can see, incidence among exposed is A over A plus B. Incidence among unexposed is C over C plus D. And the relative risk is calculated with the incidence among exposed divided by incidence among non-exposed. If the relative risk is more than 1, it means there is an association between the two factors. And if the relative risk is less than 1, it means there is no association or less association between the two factors. So it will tell us about the presence of association and that what is the strength of association. Let's take an example. For example, a group of people went to a birthday party. They ate Russian salad, and on the basis of eating of Russian salad, it was seen that there were 100 people, and out of 100 people, 33 ate Russian salad, and 67 never ate Russian salad. Out of 33 who ate Russian salad, 23 developed food poisoning. And out of 67 which never ate Russian salad, 7 developed food poisoning. So incidence among exposed will be A over A plus B, which will be 23 divided by 33. And the incidence among non-exposed will be the 7 over 67, means C over C plus D. So the relative risk will be calculated as incidence among exposed and incidence among non-exposed, and this shows a relative risk of 6.67. It means the risk of getting the food poisoning was 6.67 times higher in those who ate Russian salad as compared to those who never ate Russian salad. So this is the way how we interpret the results of relative risk. Moving forward, so this is your assignment 1. A researcher conducted a cohort study to find out an association between smoking and lung cancer. He found out that incidence of lung cancer in smoker was 10% and in non-smoker was 0.5%. Calculate the relative risk and interpret your results. This is your assignment number 1. Assignment 2. Imagine that the incidence of gun violence is compared in 2 cities, one with relaxed gun laws and the other with strict gun laws. In the city with relaxed gun laws, there were 50 shootings in a population of 100,000 people. And in the other city, 10 shootings in a population of 100,000. So what is the relative risk of gun violence in the city with relaxed gun laws? Fine. Assignment 3. A researcher wanted to find out an association between occupational exposure of beta-naphthalene and bladder cancer. He identified 1,000 workers in a rubber factory. He found out that the number of bladder cancer was reported in 45 individuals out of 350 who were in direct exposure to the chemical. and the number of bladder cancer was only 6 in the non-exposed group. Identify the study design, construct 2 by 2 table, and calculate by year of association. You have 1 hour for the submission of the assignment. From now onwards, I'm waiting for your assignments, and your presence will only be marked if you will do these assignments correctly. And if you have any questions in the meantime, you are more than welcome. You can contact me. Thank you so much.